Okay, so we're going to make some soap, and I've got all the ingredients here ready to go. I've got a hot plate that we're going to do the heating. We have olive oil, okay, and I've already measured out the 5.5 milliliters into the 150 milliliter beaker, so you can see that. I've got a stir rod to stir it, and then we're going to add to it some 95% ethyl alcohol, okay, and I've already measured out 9 milliliters of that. I have some 50% ethanol here in this jar. That's to make sure that the level doesn't go down too much as we heat it. I'm going to have to add to it some 12.5 molar NaOH. So this is relatively concentrated. So this is kind of nasty stuff. So I haven't measured that out yet, but I will. And then we're going to put that together. We're going to heat it, the ethanol, the olive oil, and the sodium hydroxide. We're going to heat it for 30 minutes, and as the boils off, we'll add some 50% ethanol so that the level doesn't go too far. And we're going to heat it for 30 minutes, okay? And that's going to saponify the oil, turn it into soap. All right? Turn it into fatty acid molecules and glycerol. Okay, once that's done, and I will show you part of that at the start, and we'll show a little bit of it at the end so you can see what it looks like. We are going to dump that mixture, once it's done, into a salt water solution that you prepare while it's heating. And so I've already weighed out 25 grams of salt. So I'm just using ice cream salt, you know, rock salt for ice cream and stuff here. And we're going to put that into 75 mils of water, which I've already weighed out. And so once we get the saponification done on the hot plate, we will pour it into the salt water bath. That'll give us our soap. And then we're going to isolate it by vacuum filtration, and I'll show you that as well. Okay. Okay, so we're ready to get started. So I'm going to put the olive oil, start that heating with the hot plate on. I'm going to add the ethanol, okay, to make a mixture that thins out the oil a little bit. Okay, doesn't really dissolve in the ethanol, but a little bit of it does. And then I'm going to add my 10 milliliters of the hydroxide. So I'm going to show you this, what that looks like there, so you can kind of see the ethanol and the oil. They don't really mix. All right, and we'll add the hydroxide, and that'll get the reaction started. And then I have to heat it for 30 minutes, and I'm going to add some of this 50% ethanol water mixture to keep the level of liquid the same. It tends to foam up, and this will keep the foam from overdoing the beaker as well. So let's add the hydroxide and get started. Okay, so now the hydroxide is dissolved in water, and as you know, oil and water don't really mix. So that's why we have the ethanol in there, part of the reason. Okay, and we're going to stir it. And we're going to heat it. Okay, so now I'm not going to show you the whole time here, but you can see what it looks like. Oops, sorry, a little bit too far. You can see the oil droplets, and they haven't really started to react yet. But it takes a while. That's why we have to heat it. Okay, so it's been about 15 minutes. You can see that it is foaming a little bit. Okay, and I've been adding the ethanol. As you can see here, I'm stirring it. I'm going to zoom in a little bit so you can see what's going on down here in the beaker. Okay, and as it foams up like that, all right, as it keeps foaming up, got my 50% ethanol water mix, and I just add a little bit of that, and that takes the foam down and keeps my level in there the same. Okay, so we got about 15 minutes down. We got about 15 more minutes to go as far as heating goes. I've got my salt water here. Still working on dissolving it, but it doesn't all have to dissolve. It will when I dump the mixture in there. So we'll come back again close to the end and give an update. Okay, so the 30 minutes of heating are basically up. You can see it's all kind of one layer now, and you can see it's foaming still. I'm going to tighten in here so you can see what's going on. Okay, and I've got my salt. It's not, there's still a decent amount that hasn't dissolved yet, so I'm going to work on that a little bit. If I heat this a little longer than 30 minutes, it won't hurt anything, the saponification, to get my salt to dissolve. But I'm going to then set up the camera so you can see what happens when I pour the saponification reaction into my salt bath. So I got to adjust the camera for that, because I'm not going to do that on the hot plate. Okay, so I've been heating for about 35 minutes. I've got most of the salt to dissolve, as you can see in the beaker there. And now I'm going to go ahead and pour the mixture that we've been heating into the salt water with vigorous stirring. Okay, and we keep going until it breaks up into chunks. Granular solid is what we need to get. You can tell there's suds in there, so that means there's soap. Hopefully we've made some solid at the bottom here. Not just a soap solution. Okay. And the other thing we're going to do is, once this cools down, we're going to stick it in an ice bath and chill it really well. And we're going to cool it for 5 minutes, and then we're going to collect it, and I'm going to wash it with some ice cold water. So I've got some water already in an ice bath. Okay. Now, let's see what happens if we let it set. Okay. You may or may not be able to see this on the camera, but if you look at the bottom, you can kind of see that there is definitely a layer forming here with some granular solid. There's definitely it's a bi-layer system. And so we're trying to get them together here. And once it cools, we should get our soap out of that. So I'm going to go ahead and stick it in the ice bath, and we'll pick it back up after that, and we'll set up for the vacuum filtration, and I'll show you that as well. Okay, our soap is chilling in an ice water bath, and we're going to isolate the soap, the solid soap that we hopefully got, with a vacuum filtration setup. And so I'm going to show you the vacuum filtration setup. You'll need a ring stand with your clamp. Okay, so I've already clamped that, put the clamp on the ring stand. You'll need your filter flask, which is the one with the side arm. Okay, you will need your Buchner funnel. which is like this. It may be in two pieces, but right, it has the holes in the top part there. You'll need your thick-walled tubing, okay, which is vacuum tubing, so it doesn't collapse. Your amber tubing will just collapse when you put it under vacuum. And you will need a rubber stopper that has a hole in it. Now, this is not in your drawer. This you would get off the supply table. And you will need a piece of filter paper, which is also on the supply table, okay? So you put a piece of filter paper. So when you're doing this, you obviously, we're going to clamp the flask. Now, the reason we clamp the flask is once you hook it up with the thick-walled tubing, it has a tendency to flop all over the place, and you can break, and it can spill things and everything else. So that's why we clamp it. So we're going to clamp this in place, okay, so it's not going anywhere. Okay, we're going to take the Buchner funnel and put it through the rubber stopper. And we're going to put that on top of our flask, like so. Okay. We're going to take the piece of filter paper, put it into the funnel, and then we need to hook up the rubber tubing. Okay. Now, obviously one end hooks onto the filter flask like so. The question is where does the other end hook up? Well, obviously we don't hook it onto this one because this is the gas tap, okay, the blue gas tap. We also don't hook it onto the bottom of one of these faucets, okay? See if I move that out of the way so you can see that, okay? What we want to do is on this center faucet, you can see it has this, what's called an aspirator, okay? And so the water flows down this way, and as it flows down this way, it pulls the air molecules off this side port. So that's where we hook our rubber tubing like so. Now, we're all set up, but before we actually use this, we have to wet the filter paper, and then we turn on the faucet, and the wet filter paper gets sucked down against the holes on the Buchner funnel, which is what makes a good seal between the filter paper and the funnel. If we don't wet it, then when we first pour some in, some of the solid or your compound may get around the filter paper. So you always want to wet the filter paper with some solvent, in this case water, and then turn on the faucet. And then before the filter paper completely dries out, you want to pour your mixture on top of here. Okay, so that's how you set up a vacuum filtration apparatus. And now I'm going to go and get our soap after it's been chilling, and we'll isolate our soap, hopefully. Okay, so the soap has been chilling a while, and you can see here we've got a good amount of granular soap here, and then there's the solution at the bottom. So this is what we're going to have to separate on our filter. We already have that set up, and I've got some cold water here to rinse our soap. Try to get as much of the hydroxide, any hydroxide that's left on there. So remember, to start the filtration, I got to wet the filter paper. So I just got my squirt bottle here with some water in it. So I'm going to just wet the filter paper. Okay, and then I'm going to turn on the faucet, and we're going to go ahead and isolate it. After I get all the stuff onto the filter, then I will take the camera down and show it from the top view so you can actually see what's going on. Okay, so I'm trying to decant some of the liquid out of here so it'll go a little quicker. Once I get all this soap on there, the vacuum may not go quite as fast. Now, I didn't put any scent or anything in there, and one of the things it tells you to do is compare it to, wash your hands with it and compare it to commercial products. Now, of course, commercial products, besides the soap, they put in lots of lotions and all this kind of thing. This does not. This is a very rough soap. So, but it will clean. At least we're going to try to see that anyway. Okay, so yeah, we couldn't make a whole lot more soap. We've got as much as fits in here. Okay. Now it will go down a little bit because it's still kind of wet as it dries here on the filter. But there's quite a bit of soap here. Okay, I also got a spatula here, and this is just kind of pressed down on it to get out, press out some of the liquid. And that'll make room so I can wash it with the cold water. And the reason we use cold water to wash it is because, of course, right, hot water, we're just going to dissolve up our soap that we just made. So we want to use cold water. We'll dissolve some of it, but not very much. All right, so we're going to wash this with a little water. I'm not going to worry about the little bit that's in the beaker, right? We're not worrying too much about yield here. So I'm just going to wash this with some cold water. And what we're trying to do here, right, with the washing of the cold water is try to get, if there's any sodium hydroxide still in there, we want to rinse off as much of that as we can without losing a lot of our soap. So we're trying to rinse it off here. We're also rinsing off the glycerol, which is the byproduct from our soap. Now, of course, this process that we just did is something your ancestors probably did, the settlers of this region, right? They had to make their own soap. It was a lot easier to make it than to wait for shipment from out east, with the railroad or on covered wagons. So they would, of course, they wouldn't use olive oil. They would use probably fat, beef fat, or buffalo fat, obviously, if they're out here hunting buffalo. Okay, so we've washed it with a decent amount of ice cold water. Okay. I don't know how much more hydroxide we're going to get off of it with this. Alright, and so now I'm just going to let it set here on the filter for a little while to dry it. It does say we could mold it into a shape if we wanted to at this point, but we've made soap. I'm going to take the camera and you can see it from the top angle here in a second. Okay, so here is our soap. You can see it there. Okay. Alright, so that's all the soap we made. Alright. On the filter. Okay, so you can see it's been filtering and there's not anything more coming down but foam, right? So it's drying out the soap as much as it can, but I think we're going to be as good as we're going to go here. So now I need to stop the vacuum filtration. To stop it, you say, okay, well, you just turn the water off at the tap. Well, if I turn the water off at the tap, there's still a vacuum in this flask, and tap water could get sucked back through the hose. So the best way to break the vacuum, or to stop the vacuum, is you got to break the vacuum first. You could either do it here at the connection to the flask, or you could do it here. So I'm going to break the vacuum over here by the tap, and then I can turn the water off. All right, and so now I've got my soap, and I'm going to scrape it into a weigh boat and we would use some of it for, we're going to use some of it for the tests that we're going to do, but the rest of it you would save, and you could take it home the next week. As it sits in air, any little bit of hydroxide will react with the carbon dioxide in the air, so it'll make it a little bit softer soap the longer you let it set. But we can try it and we can see if it works. That's one of the tests that we're going to do. Okay, so we're going to try to make some detergent now, and I've got the starting material here, which is 1 dodecanol. Okay, so this is the stock bottle, and you can kind of see what it looks like. But to get it out of here, instead of weighing it out as a solid, it melts at basically 24 to 27 degrees C, so just above room temperature. So I've got it in a warm water bath here, and then I'm going to measure it out as a liquid, 10 milliliters. Now, if you were doing this in the lab, we'll have pre-measured this and put it into test tubes, so all you would have to do is melt it and pour it out of the test tube, but I haven't done that for this experiment here. So I'm just going to melt what's in the stock bottle and measure out 10 milliliters with a transfer pipette into a 100 milliliter beaker. And then we're going to add concentrated sulfuric acid, 3.5 milliliters with stirring. And we're going to stir it for a couple of minutes, and then we're going to let it set for 10 minutes. While we're setting for 10 minutes, we're going to make a salt water bath, salt and ice. So we're going to fill that beaker half full of ice, 150 ml beaker half full of ice. I'm going to add the 15 grams of salt. Again, I'm using just ice cream salt. And then once I do that, that's going to dissolve up some of the ice, obviously, or melt some of the ice, the salt will. And then I'll add water till it gets about halfway here. And then I'm going to stick that into an ice water bath. So that's going to be my last step. So I'm going to do that once the sulfuric acid is done. Also, to neutralize the sulfuric acid and to make the detergent, I'm going to measure out 17 mils of the 2 molar NaOH using this graduated cylinder into this beaker, and I'll dump the dodecanol sulfuric acid mixture into this mixture. That'll neutralize, it'll generate lots of heat. All right, I'll have phenolphthalein indicator in there, which will go from pink to clear, so that'll I'll know that it's completely neutralized. And then I'll take this mixture. Once I've neutralized the acid that's in this with the base, I'll dump all of that into the salt, the chilled salt water bath, salt ice bath, and that'll make up our detergent. Okay, so it's a little easier process than what we did with salt, because we don't have to actually heat it for a half hour like we did with the salt. Once I get the detergent, then I will isolate it with a vacuum filtration, just like we did with the soap. All right, so I'm going to just wait until I get the dodecanol measured out, and we'll get going. Okay, so I've measured out, there's 10 milliliters of the 1 dodecanol in here, so I melted it and measured it. And now the procedure says to make the detergent, I'm going to add 3.5 mils of concentrated sulfuric acid here. And that's going to be added slowly with stirring. Okay, so I'm going to try to do this so that you can see what's going on. And then I'm going to stir it for 2 minutes. And then it needs to set for 10 minutes. So I'm going to go ahead and let this go. So you can do that while I get ready for the next parts. Okay, so I'm going to add 3.5 mils, but I need to do it slowly with stirring of this concentrated sulfuric acid. Now, turns out this transfer pipette does 1 milliliter at a time, so we'll do that. Okay, so again, I'm going to try to do it so you can see what happens. If anything. Okay, so that was the first milliliter. Okay, there's some solid stuff forming here. I don't know if you can see that. Right. But it's getting harder to stir. That's the second milliliter. Third milliliter, so hopefully you can see that it's getting thick. Okay, let me zoom in and see if you can see that it's getting, that it's right, that it's kind of thick now. I got another half a milliliter to go. Okay, so now I'm supposed to stir it for 2 minutes and then let it set for 10. Okay, so I'll bring it up here so you can see it. All right, can you see how it, well, okay, so you can see how there's this thick stuff that's on here. Okay. So it is reacting, and we'll let it stir it a little longer here. Okay, so that was 2 minutes of stirring, and I'm just going to let it set here for 10 minutes while I get the ice salt water bath going and all the rest of the setup. Okay, so it's been about 10 minutes. You can see it's really kind of thickened up. Okay, you may not have been able to see that as it was just sitting there, but you should be able to tell that it's really, really thick now. So, all right, so if I bring it up here, well, that's probably too close. Sorry about that. Let me back this out a little bit. All right, so now you should be able to see there that it's really thick. So what I'm going to do is I'm going to take this and put it into some sodium hydroxide. Okay, so the sodium hydroxide will neutralize any sulfuric acid that's still in there, and I'm going to put a little bit of phenolphthalein indicator in there. Okay, and that will turn it pink. Now the pink will fade in the base, but the other thing is it'll also fade when I add the detergent mixture there. So I'm going to add about 4 drops of phenolphthalein indicator here. 1, 2, 3. Okay. You can see it's a nice pink color. And now I'm going to add this goo here to that. Maybe actually it might be better. Now it says to pour this into there, so we'll try it. It's going to say, okay, so we got it in there. Okay, hopefully you can see that. I got a little bit more here to try to scoop in there. Okay, you can see it's now turned from a kind of a clear goo to a white, which is our detergent. Trying to get all the stuff out of that other beaker here. But again, we're not really worried about yield, so if we don't get it all, it's not the end of the world. But I did get most of it out of there. All right, well now we've got this, and it's quite warm because of course we did some neutralization, okay? And so you can see it's that way. And so now what I want to do is I'm going to put it into my salt and ice bath until it breaks up, and then it won't be so gooey to try to filter. Okay, so I have my, so there's still some little bit of ice in there because I've been chilling it, and there's salt. So it's a salt water ice bath, so it's below just 0 degrees. It's not just an ice water bath. It's with salt in it, you can get it to, -4, -5 degrees. And so now I'm going to put this, try to get this stuff into that break, and that'll break it up. And again, I'm leaving some of it behind, but we'll get the majority of it. We'll have plenty of detergent to do the test that we need anyway. Okay, so I don't need this other stir rod. Okay, so again, I got most of it out of the beaker there. Okay, there's a little bit here on the end. I'm going to try. Okay, and you can see I've got plenty of detergent in here, and it's now broken up. It's no longer kind of gooey. Okay, and so I should have plenty of detergent in here. And now I just need to filter it and wash it with some ice cold water. Again, vacuum filter the solid. Okay, that's in here. All right, that's why it's white. You may or may not be able to see it, but there's some at the bottom here that's kind of settling out as it goes. All right, so I'm going to pause the recording, and we'll get the vacuum filtration all set up. And we'll do that. And while we're waiting for that, I'll probably put this in the ice water bath and just chill it a little bit more. Make sure it all comes out. Okay, because again, right, it's water. See, we got frozen water on the outside of it here. So it is a water bath. It's in water, so the detergent is more soluble, obviously, in hot water than it is in cold water. Okay, I've got the vacuum filtration set up, reset. I just got to put the filter paper in here and wet it before I get started. And I'll show you the what the detergent looks like before we get started here as well. All right, so then I'm going to wet the filter paper here. All right, so here is the detergent. Okay, so quite a bit in there, so we'll see if do it. But of course, it's kind of dispersed in the liquid there. So we're going to filter this, right? So again, wet the filter paper. I'm going to turn on the faucet, and we'll just go here. And so you can kind of see all the white solid here that I've got. We'll see if it even all fits into the Buchner funnel here. Okay. Like I say, it's pretty full. I do a pretty good job making this stuff. I might not even be able to isolate it all. With this much solid, it takes a while for the vacuum filter to work here. Especially when I push it together, but have to in order to get any room for the rest of this. So there's still some undissolved salt in here. I'm not going to put that onto the filter. Okay, so there's some salt, and I'm not even trying to scrape all of this out of there because we can't even isolate everything. It's going to be hard enough to wash it as it is. And again, we're not really worried about our yield here. Okay. We just have to have enough to do our tests, and this is going to be great plenty. filter's having a hard time. All right, there's so much solid on here that it's having a hard time drying it. But we'll let it go. I'm going to use a little bit of this cold water to rinse it. We'll do this a couple times. Now this time we don't have to worry quite as much about rinsing it because there's not going to be any hydroxide left. We used acid and hydroxide, so we neutralized pretty much most of the nasty stuff. But we do want to wash it and get some of the salt maybe out of it as well. Okay, so we've isolated the detergent. I've rinsed it with some water. It's taking a while to filter and dry, but you can now see what it looks like. So there's plenty of white solid in here, and that's our detergent. And so I'll scrape that into a weigh boat, and then we're going to do some tests on the soap and the detergent, see how well it emulsifies some oil and water mixture, and we'll also look at see if we get any soap scum, and so we'll look at that. Okay, so we're about to characterize our soap and detergent. I mean, the first thing to do is to try it, but there's nothing really to video for that. Hopefully you'll get a chance to try some soap and detergent that students have made at some point. But we're going to do some other characterizations, and for that I need to make up a soap and a detergent solution, and I'm going to make up a solution of just sugar water. Okay, so in my 3 beakers here, I've put 100 milliliters of deionized water in each one. In this third one, I'm going to put some sugar. In the first one, I'm going to put about 1 gram of the soap, so you can see that's our soap. That's about 1 gram that I've weighed out. In the second one, I'm going to weigh just about 1/2 gram of the detergent, and so I've weighed that out. And in order to get the soap and detergent to dissolve without making lots of suds, I'm going to heat it on a hot plate, and we're going to get it all to dissolve. And then once we have the solutions, then we're going to run tests on the soap solution, detergent solution, and some on the sugar solution as well. Okay, so I've made the 3 solutions, and I'm here in the balance room where I'm going to be able to get it really dark. And so what we're going to do with this test is I've got my soap solution, so you can see that. Okay, and here it is from the top down, so you can see what it looks like. And then I have my detergent solution, and here it is from the top. And then I've got my sugar water solution, and again, see what it looks like from the top down. Okay, and so you can now see all 3 of them from the top. You can see the differences between them. But what I'm going to use is this little pocket kind of LED flashlight, and I'm going to shine the light through the solutions, and you're going to notice the difference when dissolving soap molecules, detergent molecules, and sugar molecules, which are much, much smaller. And so what we're going to observe here is what's called the Tyndall effect. Okay, so I'm going to pause it, I'm going to turn the lights out, and we'll see what we can see. Okay, so I've got my 3 solutions. I'm here in the dark. I've got my flashlight, and we're going to shine through the solutions by looking through the top down. Okay, so first I'm going to do the sugar solution. I'm going to turn the beaker. Okay, so we get everything out of the way. And you can see, looking through from the top down, all right, the light's going through the solution. You can see it here on the back wall. It's going straight through. You can hardly even see it in the solution. Okay. That's the sugar water solution. So that's, normal sized molecules. Doesn't really affect the light that much. Now when I go to the detergent, look at what you can see. See how the light kind of is diffuse and you can actually see the light beam passing through? And if I look at the wall where it goes through, you can see it's much more diffuse after it passes through the solution. What that means is the light is interacting with particles in the solution that are big enough to interact with the wavelength of light that's in the flashlight. And if I go to the soap solution, you'll see here, now it pretty much lights up the whole solution. Okay? So the whole solution's glowing because the light is bouncing off all the different particles in there. Okay, and again, if I look at the wall behind it, you can see that it's completely diffuse. All right, so that is the soap. The detergent, right? It's diffuse, and you can see the light going through, but it's not, right? It's not as bad as the soap. And then this is the sugar, right? And you can't even the light kind of goes in on the one end and comes out the other. And so the fact that the light bouncing off the particles because they're the right size in the soap and the detergent is called the Tyndall effect. Okay, so in the test tubes you see here, I've put 5 milliliters of water in this test tube labeled W, 5 mils of the soap solution we prepared in this test tube labeled with S, and 5 mils of detergent solution in this one labeled D. Okay, and so what we're going to be testing here is the ability of the solution, soap and detergent, to emulsify oil, meaning to make it soluble in water. So the one with just deionized water in it is going to be our control. And so what I'm going to do is I'm going to add 4 drops of oil to each one. The one with the water, I'm going to cap it and I'm going to shake it vigorously, and then we're going to let it set. The ones with the soap and detergent, I'm not going to shake them vigorously because that's just going to make a lot of suds. But I'll invert them to mix, and then we'll let them each set for 10 minutes. And again, I'm not going to record the whole 10 minutes, but we'll let them set for 10 minutes. We'll come back and show it. And the idea is that we should be able to observe, see if there's any difference between these. So I'm going to drop 4 drops of olive oil into each one. Doing 5 drops. All right. Okay, so the water one, we're going to shake vigorously. So we're trying to get the oil to dissolve into the water. Of course, you probably already know this already, that oil and water don't mix. So the oil will probably end up forming a layer once it sets. Now for the soap and the detergent, I'm just going to invert it a few times. Okay, so we're going to 6, 7, 8. Okay, so I'm inverted 10 times. Okay, and so now we'll give it about 10 minutes and we'll come back and see what they look like. But I'll tighten up on this right now so you can see what they look like right now. Okay, so all right, so we'll come back in 10 minutes and see what they look like. Okay, so it's been about 10 minutes. It's been sitting here, and what we're looking at is the oil layer, but of course it just happens that the oil layer is right at the spot where the test tube rack is, so you can't see it that well. So I'm going to take them out of the rack. I'm not going to. It's going to be a little bit hard, maybe a little bit harder to see. I'm going to hold them up against the white background here, so I'm going to just adjust this up so you can see it, hopefully. And what we're looking for is you're trying to compare how big the oil layer is. All right, so if I tighten it in, all right, if I can get my hands out of the way here so you can see the labels. So the one there here is the water, and that one is the other one is the soap. All right, and so you can see they both definitely still have a layer, so it didn't completely overdo it. So this is the water here. You can see there's a decent layer of oil there. That's the soap, and you can see it's a little bit smaller there. Right? There's not as much oil, so some of it has dissolved. And then that one's the detergent. So again, you can still see a layer, but the layer isn't as thick. All right, so from left to right, it goes water, soap, detergent. Okay, so detergent there. All right, and water and soap. Okay. So it does. The soap and detergent did emulsify the oil a little bit. But not as much as I would have hoped. All right, the last test we're going to do with our soap and detergent is going to be looking at soap scum and hard water. So what we've got, I've got four large test tubes over here. Each of them have soap, S plus. This one will have calcium ions in it. This one will have magnesium ions. This one has iron 3+, and this one I'm going to add tap water to. I've repeated that set with this over here, except detergent. Now, as you might be able to see, it's a little hard to see, but these, I put in 5 milliliters of soap solution in all 4 of these. In the first 3, I've added 5 mils of deionized water. Okay, so that's why there's twice as much volume. Similarly here, except with detergent. 5 mils of detergent in all 4 test tubes. The first 3, I added 5 mils of deionized water. Okay, so what I'm going to do is in the first tube in each series, I'm going to add some calcium chloride. Okay, so 5% calcium chloride. And in the second one, it'll be 10% magnesium chloride. Okay, so that's that. And the third one will be 5% iron chloride, iron 3 chloride. Now what that's going to do is these are the ions that are in hard water. Now obviously 5 and 10% is harder water than you're ever going to see anywhere. So these are completely positive controls. You're going to, if there is going to be soap scum or any kind of something going on, you're going to see it. All right, no tap water is going to be that much. Even once we dilute it with the 5 mils of deionized water, that's why I put those in here. Okay. The last one I'm going to put in 5 milliliters of tap water. Okay, that's just Abilene tap water here out of the sink. I've got it already pre-measured for each one. So what we're going to do is compare our tap water to see how hard it is, see if it shows up the same way as the ones that, you know, that are way overboard with hardness for calcium, magnesium, and iron. Okay, so I'm only adding 3 drops of these solutions plus that 5 mils of deionized water. So it's going to make it a little more closer to what you would find in really, 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 really hard water. But that's about as much as we can do. So I'm going to go ahead and add the calcium here. I'm only going to add 3 drops into the first tube here of each set. And then I will mix these so you can see what happens. Okay, so that was the calcium. Now I'm going to add the magnesium. Again, 3 drops. And then the third test tube, I'm going to add 3 drops of the iron. Of course, iron has that rust color. And then in the fourth test tube in each one, I'm going to add 5 mils of Abilene tap water here. So now they'll have roughly the same amount of water on each one. Okay, so the 4 on the left have soap, the 4 on the right have detergent, and now I've got to stopper and mix these a little bit. Okay, so hopefully you can see that that one has some solid floating in it. That one looks really kind of nasty. Again, I'm trying not to make too much mix it, but not make it just all suds. Okay, so there we go. All right, so what you want to do is, if you're going to compare, we could do a couple of different comparisons. One, you can compare the tap water to the ones that have the hard water thing. And you can see on this one, and I will zoom in on this later, but you can see there's white, chalky kind of solid here at the top. All right, and for the calcium with soap. Magnesium also, you can, right, there's chalky solid there, you can see it. Hopefully. It's a little hard to see because it's white. The iron one looks really, you can describe that your own color, but right, that's kind of nasty looking. And here's the tap water, and you can see that, soap solutions are a little bit cloudy, but right, that might be a little more cloudy than than it was with just the soap. Right? So you might have some amounts of this white solid that you're seeing here in here. Looks like we don't have very much iron in there, not enough to make it colored anyway. Okay, so you can compare these three with the tap water solution, but I can also compare what happens. I can do the same with the detergent, but I'm also interested in the difference between the soap with hard water and the detergent with hard water. So if you look at the detergent with calcium, there's no solid in there. I mean, it's a little bit cloudy, so there might be a little bit, but not much. The magnesium with detergent, almost clear. The iron, right, again, it has a little bit of color to it. That's because of the iron, but it doesn't look like that one as far as how much solid is in there. All right, so if I put so that's the detergent with magnesium. That's the soap with magnesium. All right, and here's the two calcium. So that's the soap with calcium. That's the detergent. So you can see that it's much clearer. And then here's the detergent with tap water, right? So you're not seeing any kind of cloudiness, right? That's probably the easiest one, right? If you look at tap water with detergent and tap water with soap, right? So that's kind of the, you can use this to say, okay, well, why do people put detergents in things and not soap? Well, this is your answer, right? This is going to leave a ring on your tub, or hard water stains basically everywhere with soap, whereas detergent, you don't get that, right? Especially things in your hair or your skin or any of those kind of things. All right, so I'll zoom in until you can see these a little bit closer. Okay, so you can make your comparisons, you can kind of describe them. You might be able now to see the solid over here where you couldn't see it before, but there's definitely some solid in there. And okay, so this kind of tells you why we use detergents mostly now instead of soap, right? But of course, detergents are made through a chemical process, whereas soaps, right, they've been known for many, many, many years. Detergents are a lot newer invention.